Last time we were looking at molecular formula and empirical formula, and we discussed how differences in molecular formula may be accounted for different chemicals. But it turns out that there's a different property of molecules which really gives rise to their overall chemical reactivity, and that's the structure of the molecule, the molecular structure. A lot of this class is going to be focused on studying molecular structure, and understanding all of molecular structure in one lecture is definitely impossible. So what we're going to do today is just look at a brief introduction to molecular structure. This will be a very short movie. And then what we'll do is we'll move into atomic structure in the next lectures, protons, neutrons, electrons, that sort of thing, and how the basic elements are built. From there, we'll build up into molecules and start to really understand molecular structure. So let me get my notes up in front of us. Okay, so we were looking last time at the molecules formaldehyde. Actually, I'm going to give myself a little bit more space. Sorry about that. We're going to look at, last time we looked at formaldehyde and glucose. And I also want to look at acetic acid. I like these examples because it allows us to further kind of illustrate the shortcoming to the empirical formula. Now, the empirical formula is very useful because it provides the ratio of the elements that make up the molecules that we're studying. But as we've seen in the past lecture, it has some shortcomings in that we could have some coincidentally identical empirical formulas for very different molecules. And that's the case here. If we looked at formaldehyde, it had an empirical formula of CH2O. Glucose has an empirical formula of CH2O. And it turns out acetic acid also has an empirical formula of CH2O. Now, some common, I'm going to label this row as common properties slash names. Okay. And I think the common property of glucose is that it's table sugar. So kind of the sugar that we add when we're cooking, that sort of thing, is glucose. That's very different from formaldehyde. Formaldehyde is a preservative agent. And as a result, it's highly toxic, among other health consequences, if it's directly consumed. Acetic acid has kind of an interesting name. It has the word acid in it, which sounds sort of scary. It's really actually kind of a weak acid. It has a bigger issue of being flammable and that sort of thing. But it's actually vinegar. So when we bake with vinegar, concentrated vinegar would be acetic acid. The active ingredient in kind of our baking vinegar is acetic acid. So when you hear acetic acid, you could think vinegar. Now, like glucose and formaldehyde, the empirical formula of acetic acid or vinegar is CH2O. Now, what we see here is that we have very different properties. In the first case, formaldehyde, we have a toxic agent. Glucose is a tasty table sugar. I mean, it could be toxic in large doses. I guess the dose makes the poison, but you know, we consume table sugar all of the time, and in the short term, there aren't any drastic health consequences for most of us. Similarly, we could consume a great deal of vinegar in very dilute forms, and it would taste kind of weird and bitter and bad, but it wouldn't be as devastating as consuming that much formaldehyde. So we have very different properties in every case. I mean, even though vinegar is safe to consume when it's diluted, having sugar water would be a lot tastier. So we can get some insights into why these things have such different properties by looking at their molecular formula. So the molecular formula of formaldehyde, we said last time, was actually identical to its empirical formula, CH2O. Glucose has a few more carbons, but it maintains the same ratio of oxygens and hydrogens in its molecular formula, CH2O, to give us a total molecular formula of C6H12O6. Now, acetic acid has C2H4O2. Okay, so what we see is that even though the ratio of the elements is all the same, carbons to hydrogens to oxygens is all 1 to 2 to 1, the fact that we have different numbers of carbons, hydrogens, and oxygens allows us to see maybe why we have different molecules in all cases. It turns out, though, that the structures of these molecules are also very different, okay? So what I'm going to label here is the molecular structure, and I've left myself most room for formaldehyde, which is the smallest molecule. And so at this point, we would say the molecular structure is a carbon that's flanked on either side by hydrogens that are connected with these lines. And then we have 2 lines connecting a carbon to an oxygen atom. That's going to provide us with the molecular structure. Now, before we get to the other 2 molecules, and I'm going to just give myself some more space for glucose and a little bit more space for acetic acid. Before we get to these, though, let's kind of define molecular structure briefly. And a molecular structure is the 3-dimensional arrangement of atoms. And remember, when I say atoms, we could think about that being synonymous with elements on our periodic table. So our atoms or our singular elements on the, that comprise the molecule. So the 3D arrangement of these atoms in a molecule. Now, a feature of these are the atoms are connected by chemical bonds. And we'll talk about what types of chemical bonds we use in future lectures. Covalent's the most popular one if you've heard of these things before. So I'm just going to, for now, call them chemical bonds. Okay, squeeze that in there. Okay, so the molecular structure of table sugar or glucose is actually a fair bit more complicated. And so I'm going to, it has kind of a hexagon shape to it. We have hydrogen being connected to, sorry, it looks a little sloppy. Let me clean this up a bit. Give myself some more room here. So we have C connected with a chemical bond to a hydrogen and another hydrogen, and then the C is connected to the OH. Now, this is just one of 6 C's. The other C's actually form the bulk of a hexagon. Now, we've also only drawn 1 oxygen. 1 oxygen finishes up a side of our hexagon, and the other oxygens are connected to carbons around the outside of the molecule. Okay, so now if you count, we've got 1, 2, 3, 4, 5, 6 oxygens, it looks like. And what about our hydrogens? We're going to add hydrogens to the oxygens that aren't part of the hexagon structure. And then we're going to add a few hydrogens to some of the carbons. I'm just going to do a quick scan. 2, 4, 6, 7, 8, 9, 10. Okay, I think that is all of the hydrogens that we need to get us to 12. Okay, that structure is very complicated and big. Acetic acids is a little bit smaller. We only have 2 carbon atoms to worry about, and as a result, we've got a much simpler structure to deal with. So what we see in the case of formaldehyde, which was shown here, is a small structure. If you're somewhat familiar with chemical bonds, this looks manageable. Okay, we just have 4 bonds to deal with to help connect our 4 elements. With acetic acid, it gets a little bit bigger. Okay, we've got 2 carbon atoms now, and then twice as many hydrogen atoms that we have to kind of fill around the outside of one of the carbon atoms. But for the most part, that's also manageable. Now, glucose in the center here has kind of a hulking and complicated structure. Don't worry, we'll get to glucose in due time. This isn't a lecture where you want to see the chemical things that I draw and commit them to memory so much. You want to know the ideas behind molecular structure, that is the definition of molecular structure. That's something to know. You want to know kind of how an empirical formula relates to a molecular formula. And then you also want to have some idea about how molecular structure and molecular formula are more helpful in defining the chemical properties of a molecule. So again, we'll keep this one short. If this one was a difficult one to digest, don't worry, it is for many people that haven't seen chemical structures before. We're going to build up to chemical structures through a big part of this class. It can't be taught in a lecture, especially a lecture as short as this one, as I'm wrapping up. But this is just some introduction to, so that you can see, hey, why are we going back to protons, neutrons, and electrons, which will be the next lecture. And the reason why is because we want to build up to structures this complicated. So let's go ahead and get glucose out of there, and we'll end this lecture for now. And again, next time we'll pick up atomic structure, looking at the fundamental properties and the fundamental building blocks of atoms.